Hi. So in this video, we're going to actually solve some examples on the integrating factor and the separation of variables method. So as you can see here, you can clearly see that this is of the form y prime plus p of t times y is equal to q of t. Definitely of that form, I can assure you that. So when you're going to look at this, the next thing what you have to find is what is p of t and what is q of t. So all the other terms except y is going to go under p of t. So in this problem we have p of t is equal to minus 1 over t, and our q of t is going to be 5 minus t. So how we're going to solve this one is we're going to first find the integrating factor, because we know that's how we're going to solve it. And that's going to be e raised to the power integral of minus 1 over t dt, but it's going to be p of t times dt. And I can take the negative sign out, so when I do that, I'll end up with integral of dt over t. I know that it's going to be ln t, so I'm going to do that directly. And remember to have the modulus sign on, it's your basic calculus. And plus c is not actually necessary when you're going to do the integrating factor. I would encourage you to do the plus c towards the end. So you're going to end up with this. And as you've learned from this module from the first video, that whenever you have exponentials and logarithms, you should always know how to simplify them, because if you're going to have logarithms and exponentials in the same equation, you're most likely going to get rid of both of them. That's the advantage. So I'm going to move this negative sign to the power. So I'm going to get, which is equal to e to the ln of t raised to the power minus 1. When I do this, I can just cancel out e and ln and it becomes 1 over t. Isn't this one much nicer? So this is what we need. So this is our integrating factor. So as you might have remembered, when you're going to, actually for your examination, you're supposed to go through all the steps which I covered in the previous video. But just for simplicity now, I'm just going to calculate the final y of t directly. So you would be having integrating factor times, you're going to have the function y of t is going to be the integral of q of t times the integrating factor times dt. So when you're going to plug in this one, you're going to get y of t is equal to 1 over the integrating factor. So when this is going to come here, 1 over integrating factor, so you're going to get 1 over t, so you're going to end up with t. And for the integral, you're going to end up with 5 minus t times 1 over t times dt. So on simplifying, you're going to get, oh, I'm sorry, I forgot the integral. Yeah. So you're going to get integral of 5 over t dt and minus t over t, which is going to be minus 1 times dt. So I'm just going to simplify this for you. So 5 over t is going to be 5 times ln of t and minus t, and over here it's important to include the plus c. And remember, you can't bring this plus c outside, because you already have the integrating factor before the integral, and the plus c is going to be part of your integral always. So it is not right to put the plus c outside, and you're always going to multiply, so you'll end up multiplying with the integrating factor, 1 over the integrating factor. So when you get this, you're going to get it as 5t times ln of t minus t squared plus ct. So this is going to be your final answer for y of t. Let's say I'm giving you an value. Let's say I'm going to give you y of 1 is going to be 0. All this means is that when time is equal to 1, without unitless, I'm saying here, but when it's going to be, let's say 1 second or something, whatever it is, then the position of y is going to take the value 0. So y of t is going to be 0, and I'm going to plug in. If this is true, then t should be 1. So I'm going to plug in t is equal to 1 everywhere. So if you're going to look at this, you're going to get 5 times 1 times ln 1 is 0. So this term is again going to be 0. And this one is going to just be minus 1. And over here, you're going to get plus c times 1 is c. So I would get therefore c is equal to 1. How do you go for the next, the particular solution for this? All you're going to do is you're going to bring it back saying that y of t is equal to 5t ln of t minus t squared plus t. This is going to be a particular solution. I'm just sorry for cramping this in a little space, but that's how you're going to do it. Let's look at the next example now. My next example which I've given you is dy over dt is equal to t squared plus y squared. Before you go ahead, just think whether you can do this by separation of variables. Since you're going to have an addition term over here, there's no way that you can separate to all the y on one side and all the t on the other side. It's impossible to separate. So what do we do now? We're going to look at the other way of solving that we know. That's the integrating factor method. But can integrating factor work over here? It is actually not possible because if you're going to take this as 1 and then you're going to have 1 times y squared, so it's not a linear equation over here. Since it's not a linear equation, the integrating factor method is not going to work on this. Remember, it should always be of the form dy over dt plus p of t times y, not y squared, not anything else, is going to be q of t. We have q of t correctly, but then our p of t can be taken as 1, but it's not y squared. Okay, it should be y to be solved through the integrating factors method. So what homework which I would give you is make this into y and try solving the integrating factor method. Remember, it's very important to practice because integrals, you can make a lot of mistakes. You just saw me like missing out on an integral. So there can be many mistakes. You might forget this plus c, or there might be a mistake during this. So it's always better to do it. Maybe just for an example, I can give you y of 0 is equal to 1 as your initial condition. You can try it with that. Finally, I'm just going to go over this question. So there's actually a little trick that's involved in this. So you can actually do this. You might think that it's going to be a linear equation. Honestly speaking, it is a linear equation. You can do it in two ways. The first way is you can take dy over dt as t squared plus k times y. Over here, you can do two methods. The first method I would not suggest you to do is taking p of t is equal to t squared plus k. You can integrate that, get your integrating factor, and definitely your q of t would be 0 in this case. It's again easy because you don't have the right side anymore, but it's all up to you. But my method of doing this would be just when you come to this stage, you know that you can easily separate it because k is just a constant over here. So all we can do is we can go for dy over y is equal to t squared plus k times dt. And the integral would just be ln of y is equal to t squared. When you integrate that, it's going to become t cubed over 3, and plus k is just going to become plus kt. Remember, although I have a constant here, it's actually not completely necessary to go for the plus c. But since the value of k is not given, and if the question says that k is going to stay constant throughout the time, then it's no longer acts as the plus c which we actually need. It's just some other different constant. So it's definitely better to go for another plus c. C can actually be 0, but we can't assume that it's going to be 0. We have to always look at all the possible conditions. So it's very important to go for plus c. And I would suggest you to go for y of 0 is equal to 1. When you're going to do that, ln of y is going to be ln of 1. So you're going to get 0 on the right side, and you're going to get 1/3 plus k times 1 is plus c is 0. So you're going to get c is equal to, when you move this to the other side, minus k minus 1/3. Don't worry when you get something like that, because k can be something neat. what if k was minus 1/3? You can get 0. Or what if it was minus 2/3? So then you're going to get 2/3 minus 1/3. That's going to be 1/3. Now the next thing what you need to do is, you're not completed the solution in this stage actually. All you have done is you found C. I agree to that. But you've still not found the solution, because the solution to this differential equation is going to be in terms of y of t. So when you're going to do that, you're going to end up with this form, and you're going to move this over here. So you're going to get e raised to the power t cube over third plus kt, and for c you're actually having minus k minus 1/3. So when I'm going to do this, this does not look really nice. So what I'm going to change is, I'm going to just take k in common so that it becomes easier. So I'll just change this term to k times of t minus 1. Just a little bit nicer. But remember, when you don't have an initial condition like this, you're not allowed to do this. So this becomes a particular solution for us. But if it's a general solution, all you need to do is, you're going to stop with this, and you're not going to evaluate any of this. And your answer would just be e raised to the power t thirds t cubed times over 3 plus kt plus c. You're not supposed to do anything more when they ask for a general solution. So these are just some examples, but definitely these are not enough for your exam practice. You should definitely look at more problems, and I've just covered the basic concepts of how to go about solving these problems. Thanks for watching this video.